My name is Jared Anderson. I am a on-site technical support mechanic over here at USA Clean, and I would like to welcome you guys to our propane buffer webinar. Now, a couple things I want to go over pretty quick here. You're all going to be muted, and please save your questions till the end of the webinar presentation. All questions should be asked through the chat feature down there in the bottom of your screen. If they're pretty easy, I can go ahead and answer them through the chat or visually. Otherwise, we'll email your answers to you at the end of the presentation. Alright. Propane buffers. We're going to go over major components of the propane buffers. We'll hit on some common issues and go over some recommended maintenance. Now, major components, really is only two. You've got the engine and you've got the frame. Sometimes the handle is also you could separate it from the frame, but handle and frame are usually going to be in the same piece. Engine types. Now, the propane industry is probably a shell of what it used to be as far as small engines. So you've got your Kohlers, your Briggs & Stratton, and Onan. Those are all now obsolete. And it hurts because I used to work on the Onan Performer quite a bit. I love that engine. Mostly now you're going to have Kawasaki. Probably 80 to 90% of buffers you'll see will have the Kawasaki motor. Hondas are pretty popular with the small 21-inch propanes. Robin is coming out too. I haven't really seen any Robins in the field yet. Mostly Kawasaki's. Okay, let's go over some engine parts. And if any of you guys are former gearheads, you probably recognize quite a bit of these. So, we'll start air filter, and usually includes a pre-filter. Air filter case. Camshaft. If you're not familiar with the camshaft, it controls the timing of the valves in relation to the engine crankshaft as it spins. Rarely will they ever have to replace one. If you do, you better just replace the engine. Carburetor. Most, especially the Kawasaki's, will have a carburetor on the front. Now, the carburetors for propanes are usually just a holdover from the gasoline versions. So all the metering jets and the floats in the bottom won't even come into play with the propane. Basically, all you're going to use is the butterfly and just a small orifice that the propane flows through. Crankcase is going to be just the whole block. Cylinder heads. If you work on Kawasaki, you'll be really familiar with the cylinder heads. These contain the valves and rocker arms, push rods, parts of the valve train that the camshaft controls. Dust bonnet. Most of these are going to be air-cooled engines. So your dust bonnet keeps the dust from getting onto the outside of the cooling fins around the cylinder head and the crankshaft. I have heard of water-cooled engines out there. I don't ever see them, but I have heard they are out there. Dust bonnet cage holds the dust bonnet foam. Emission sensors. This is that little red light that's going to get annoying for you guys when you work on these. Fan. Like I said, these are air-cooled. That fan draws outside air, blows it down over the cooling fins. Hopefully filtered properly by your dust bonnet. Muffler. Noise. Emissions. Oxygen sensor that ties back into your emission sensor. That's going to measure the amount of unburnt oxygen in your exhaust stream, and based on the voltages of that, it'll tell you if you're running hot, lean, rich. Intake manifold. Carburetor bolts to the intake manifold. That brings your air fuel inside your cylinders. Governor arm. This little guy is actually down near the bottom of the engine, near the front. And most of these engines have a internal governor that control a rev limit. As the engine spins too fast, it will pull back on that butterfly and shut off the air coming in to slow the engine down. Can be problematic sometimes. Ignition modules on the Kawasaki, you've got one for each spark plug. Some will have a big coil to control both spark plugs, like the Onans used to. Oil filters, Self-explanatory. Oil pressure switch. This guy will keep an engine from turning on if there's no oil in the crank case. There's usually some kind of bypass system when you've got in your start mode, it bypasses the oil pressure switch, the engine will fire. Once it fires, it will build pressure, so when you release it off the start section of the key switch, it'll stay running. Crankshaft, it's the main rotating mass inside the crankcase. It's what turns your pistons. There's your pistons, spark plugs. Starter, just like a car. Stator, this guy builds the electricity as it spins, so that will power itself for your spark plugs and your ignition module. It doesn't draw off the battery. The battery is only for the starter. The stator powers your ignition. Throttle plate. Now this isn't the throttle plate like many people think. See, me as a gearhead, when I hear throttle plate, I think of the actual butterfly inside the carburetor. No. This plate has all the levers and springs that control the carburetor. Your throttle cable that runs from your handle is going to tie in down here. And you can have some adjustments down in here too with little stop screws. And your voltage regulator. This is what will keep your battery charged while it's running. That guy can be cause of trouble sometimes too. Okay, now onto the frame. We'll go pretty quick through this. Alright, you got your battery. It's usually off to the side of the back. Belts around the bottom. Belt tensioner. Rear caster. Rear caster only comes into play when your pad is tipped up. When you got the machine rocked back and you're moving side to side. When that pad's on the ground, that rear caster never touches. Should never touch. Center lock holds your pad on the pad driver. High pressure hose. This guy runs from the tank to the regulator. And then your low pressure runs from the regulator to your carburetor. Fuel lock off, that's your safety feature. If at any point you ever lose ignition or you lose your vacuum, that shuts off the fuel. And our fuel regulator, this guy takes high pressure propane from the bottle, goes to low pressure fuel into the carburetor. Handle adjustment, tall people, short people. Handle grips, comfort, because it does vibrate quite a bit. Hour meter, you need to know where this guy is because all your maintenance is going to be tied off the hour meter. Key switch and key, pad driver, and pad. Spindle assembly, this is what spins your pad. Has bearings, they can go out and they can be out of adjustment too. And this, if you have a buffer that pulls hard to the left or doesn't want to move forward, there's adjustments you can do on that spindle to set that angle just right on the floor. Tank strap holds the bottle. Wheels, if they get flat from sitting too long, they bounce, wobble, whatever, that'll make a bad impact on the floor. Clutch switch. Kawasaki's like to use an electronic clutch. So this is basically just a micro switch tied into the bail assembly or the throttle cable assembly. Onins like to use a little friction clutch where as soon as that engine hits a certain RPM, then it engages the belt. But most often you're going to see electronic clutch. Dust bag. This is an optional feature. A dust shield. You're going to generate dust when you're buffing the floor. And this guy keeps it out of the air. Tries to keep it out of the air, I should say. Starter solenoid, just like a car. And your throttle cable. Now they'll usually either be like as you see here, like old lawnmower style, where it's a lever forward and back. Sometimes they're tied in with a bail handle. Or trigger grips. A dead man's grip, I guess what they call that. Okay, fuel system overview. Like I said before, you've got high pressure propane in your bottle, usually around 200 psi. It'll pass through your lock off, and then at your regulator, is going to drop it down to about 5 psi. So you can see we've got a big swing here. That 5 psi then runs through your carburetor and then into your engine. Okay, let's do some common issues here. I might have touched on them already. Engine will not turn over. Engine will turn over but not start. So you're cranking but it doesn't fire. Then engine will start but runs poorly. This you can hear. It runs rough as all can be. Reasons for a bad smell are red emissions light. Bad smell, it's going to be like a sulfury almost. And then loud noise coming from underneath. So, not turning over. Weak, dead battery, or your battery connections are unplugged, disconnected, or damaged, corroded. Your starter solenoid is bad. Your solenoid takes your low amp draw signal from your key switch to control the high amp draw, high current signal going from the battery to the starter. If that ever doesn't close correctly, it just won't start, even though you do show full charge on your batteries. So solenoid to look at in that case. Starter's bad, and not only is it bad as far as the electronics inside the starter, but bad as the Bendix gear drive on top may not be engaging with your flywheel. And finally, wiring or connections between the key switch and the starter are unplugged, burnt, or damaged. That's simple wiring, or just a bad key switch. Now, if your engine does turn over, it will not start. Here's the things to check. Your fuel supply. Is your tank full? Oil level. Do you have oil in your crankcase? Because like I said, that oil pressure switch will keep an engine from turning on if you don't have oil. You'd be surprised how much that's overlooked. Oil filters. If a filter's dirty enough, you're not going to draw enough air into fire. Compression. This ties in with the heads and the valves. If you don't have compression in the cylinder, you're not going to get a proper mixture in your combustion chamber, and it won't fire. Spark plugs, bad spark plug or spark plug with a poor gap, you're not going to get that spark to fire. And throttle cable position. That could be a bad cable, broken cable somewhere. You could be moving that lever back and forth, and that butterfly valve just doesn't move at all. Engine starts but runs poorly. Low on fuel is another one. Spark plug boot. Boots can get pulled off pretty easy and you won't know it. Especially people walking by the machine when it's not being used. They could brush up against it, pull a boot, damage a wire, and that won't get that plug to fire. Which could also cause it to, next stop, running on one cylinder. Engines running on one cylinder can be due to, like I said, the spark plug boot, or internally a push rod could have fallen off the rocker arm, which will keep a valve from moving, so you're not going to get either a full fuel charge or it won't pull the exhaust out. Bad compression, no compression could be caused from that. No spark, defective ignition modules, bad wires also. Dirty air filters. If the dust bond or air filters get too dirty, then insufficient air is getting to the engine to make it run correctly. Oh, the emissions light. So, we got quite a few things up here. Dirty dust bonnet. While the engine is running, air is pulled down through the bonnet, down through the engine to cool it during operation. If this bonnet gets covered with dust, even a thin layer, then the engine won't cool correctly. And as a result, the engine's going to run hot, harder. It can cause carbon dioxide to go up. So it's important to keep that clean. Air filters. When the engine is running, air is pulled through the air filter into the carburetor when it mixes with the propane. If the air filters are dirty or not inspected, cleaned, or replaced on a regular basis, then the incorrect mixture of air and fuel is being drawn to the engine, causing it to run poorly and get carbon dioxide emissions to go up. Make sure we keep our air filters clean. And that all ties into lack of service. We like to recommend the engine service with new filters, spark plugs, oil filter, and oil at least every 100 hours of use. If you figure around 3 hours a day, for a month, there's about 90 hours. So, just around a month. Valve setting, not to spec. Now, we recommend setting your valves about every 200 hours to keep the engine running clean and at optimal performance. We have step-by-step instructions online to show how to set valves on the Kawasaki FH500V, FH541V, and the FS481V. That's the new Kawasaki 18. It's a fairly involved process. I'd recommend reading those guides. Now, a valve not to spec can give you low compression. Low compression, you either got a leak in your valve setting or a leak in your gaskets, cylinder head gaskets. You could even have a crack in your cylinder head that can give you a low compression. Tight valves could not allow enough air in or expel enough exhaust out, which can cause a red light emissions because of high carbon monoxide. Check and setting the valves regularly will keep compression at correct levels. No compression. This is even worse. No cylinder head compression on one or both cylinder heads can be caused by a push rod falling off the rocker arm or the intake exhaust valves getting stuck open. If no compression is found in one or both cylinder heads, the valve cover on that one side needs to be removed and the cylinder head inspected to determine the cause of no compression. No compression on a cylinder head will cause the engine to run poorly with incomplete combustion and will cause carbon monoxide to build. Something else that can cause no compression is bad piston rings. If you ever run into that, that's a handful to repair there. Falls into just get a new engine. Defective or disconnected oxygen sensor. The red light on the emission sensor will flash on and off if it detects no signal from the oxygen sensor indicating that the oxygen sensor is bad or it is disconnected. If the red light on the emission sensor flashes, check the oxy sensor connections or replace the sensor. So if the engine is running out one cylinder, this can be caused by one of the ignition modules going bad or not supplying the correct amount of spark to one spark plug. A spark tester can be temporarily installed between the spark plug boot and the ignition module to determine if the spark plug strength of the module while turning the engine over. This is a little red light in between two wires, and they go one goes onto the spark plug boot, one goes onto the spark plug. And you run the engine, you can see the light flash every time that module fires. Usually you want to look for consistency between both sides. Blown fuel regulator, normal operating fuel regulator will reduce, like I said, 200 to 5 psi. If the diaphragm inside the regulator tears or blows open, then the regulator can allow all 200 psi of fuel into the engine. Engine can't handle that, and you can have a lot of unburnt fuel getting passed through. It can wreck catalyst inside the muffler. Frosting on the fuel regulator. You'll see this often when you have a propane tank that's been overfilled. Liquid propane entering and passing through the regulator and it's causing the frost to develop outside. That's because of all of that liquid propane as it expands into a gaseous form. That causes a huge drop in temperature. So when you're going from raw liquid propane to the gaseous state, as it passes through this regulator, that's where you frost over. If the frost on the outside regulator happens, the machine needs to be turned off immediately and venting procedure performed below. I'll get to that in a second here. Liquid propane can and will damage the internal parts of the regulator and cause permanent damage to the diaphragm. That's a rubber material. It's going to freeze, it's going to crack, it's going to break. This will cause extremely high CO emissions, leading to the replacement of the regulator. Overfilling a tank must be taken. An overfilled tank must be taken outside, away from people and buildings. Do not open the valve with your bare hands. You want to get a good thick pair of leather gloves to do this. And if you're uncomfortable, don't do it. But put on protective gloves and glasses. Standing away from the valve, use a pair of vice grips and turn the valve counterclockwise to open. The propane will vent out of the side of the valve towards the outside of the tank. Walk a safe distance away the tank so you don't breathe the propane vapors. Allow the valve to vent for several minutes. When finished, turn the valve clockwise to close completely. A properly filled tank should be at least 80% full for proper propane vapor delivery of the regulator. Repeat if necessary until no more frost develops. Like I said, if you're not comfortable doing that, don't. Call your supplier. There's got to be a propane company around where you live and tell them it's too full. And they can probably handle that for you, probably for a small fee. Alright, next, defective emission sensor. Basically what is going on with that is you've checked your engine over, you've got oil in it, you've got your valves are set, your compression is right on 120 psi each side. You've run your sniffer through your muffler and you've got under 100 parts per million of carbon monoxide. The buffer's running fine, but you still got a red light. And obviously, that's your emissions light. It's just not reading the correct values. It's not interpreting the values correctly, so it's going to flash a red light. So if all your other variables are correct, replace your module. Loud noise underneath. You'll hear a grinding. It might sound like a dull roar. That's the kind of noise you're going to hear. Maybe a squeal of the belt. So that could be an issue with your belt not being tensioned properly. Clutch not engaging correctly. The belt's worn. The belt's stretched. To do this, you're going to have to tip your machine over on its side. Pad driver removed and each part on the inside inspected and spun by hand to determine where the noise is coming from. That's pretty easy to do. Be careful when you have it tipped on its side. I think we'd say to the right side. That's the operator's right. This is to help prevent the oil from draining back into where it can get into your intake valves, intake system. And if you're really worried about it, drain your oil and then tip it off to the side. But if you tip it too much and it gets in, you're going to smoke profusely when you restart this engine. It'll be bad. Be sure you take it outside and probably have to run for almost 10 minutes to get all that oil burned off. Alright, to the maintenance. Like I said before, we recommend service about every 100 hours, which could be a month, maybe 2 weeks, depending on how heavy you use the machine. So every 100 hours we want to install new oil and filter. Scratch your hour reading on the side of the filter. That way you know when you changed it last. New pre-cleaner, new air filter, gap install, new spark plugs. Kawasaki's, I believe that's 35 thousandths. I'm not sure. We'll check that later. Check and replace spark plug wires if damaged. Check spark on both sides with your spark tester. Or if you're an old school mechanic, you do the screwdriver trick. I won't tell you what that is, but old mechanics know the screwdriver trick. Put in new oil to proper level. Grease your wheels and bearings clean and replace your dust bonnet. Pressure wash and clean up. That's talking about underneath the machine. Pressure wash all the old floor dust off. And make sure you get up on the sides of the engine and you're pressure washing the cooling fins. Because if those get clogged up with dirt, the engine's going to run hot. And an engine that runs hot doesn't run well. Also, during your 100-hour service, you can do things like check your battery for charging voltage as it's running. You want to get close to 14 volts, just like a car, as it's running. Test for correct compression on both cylinder heads. On the Kawasaki, like I said, I believe it's around 120. Check and test muffler for safe and correct CO levels. Correct if necessary. That goes back to our red light discussion. Check valve setting and set valves if necessary. Should be done every 200 hours. Or if you see an issue with your compression, go and check your valves. On the Kawasaki's, I want to say that's like a 6 thousandths, 5 thousandths setting gap between the two. Check out our guides on that. They're really nice. Check for and fix any oil leaks on the Kawasaki's. That fill tube has a little rubber O-ring. That guy can break and it'll leak oil when you fill it. Check for proper orientation and fix problems with the key switch, battery cables, starter, fuel hose, lock-off, regulator, throttle cable, clutch, belt bearing, pad driver, pad holder, wheels, hour meter wiring, tighten any loose hardware, etc. Basically, you're going to you give the machine a once-over and look for anything that could be broken. Then do your test run, check for proper component machine operation. And you're also checking to make sure you shine the floor, make sure your shine on the floor is even, that you're not burning one side, not the other, that you're not scratching. Center locks can scratch if they're not pushed in all the way. Dragging wheels can leave marks on the floor and tends to send store managers pretty irate. Alright. Thank you for attending this webinar. As a reminder, If you've got any questions, I don't see any questions right now. I would have responded via email or right now. If you have any right now, go ahead and put them in the chat feature. If not, you can email us at usaclean.com or give us a call. Thank you guys very much for attending my webinar. See you guys on the next one.